Hello students, today's agenda is to check homework. We'll be combining functions through applications and you will be able to work on 8.3. Today students will be able to solve word problems related to combining functions and embedded functions. This is 8.1 in this unit and this is 8.2 in this unit. If you need to review those, you are welcome to go and check those two videos either after you finish watching this or before starting to watch it. Before we go on to our lesson, I invite you to check us out in TikTok at MathMaria7 for fun encounters with math, science, and art, in addition to others. Okay, for number 1, it says, Bertha sells cakes. She uses 3 toppers to decorate each cake. So we can say that those are the information. She makes 6 cakes each day she opens her bakery. And then finally, if she opens 255 days this year, how many toppers does she need? How would that be represented? So the first thing that we can do is create from the first sentence, we can create the first function. She uses 3 toppers to decorate each cake. So we can say that f of x is equals to 3 toppers per cake for each cake. Anytime that you see the words each, per cake, a cake, that means each cake will get that much. And that's when you put whatever they get and for each one. And this will represent the number of, in this case, cakes. So number of cakes. What does that mean? When you multiply the number of cakes times the toppers that you need for each one of those, you multiply that and you get a total number of toppers. Okay? Total number of toppers. And those are the decorations that they put on top of the cakes to make it a specific theme. For example, we had a birthday party this weekend and we use Winnie the Pooh toppers. Now for the second one, it says she makes 6 cakes each day. So that will be our second function. G of x equals 6 cakes each day. Again, in this case, x represents, how do we say? 6 cakes each day. So that means that that represents the number of days. And when we multiply the 6 cakes that she makes every day by the number of days that she works, then that gives a total of, and I'm going to move it a little bit, a total number of cakes. So total number of cakes. In the question, you will find whether you're going to put f of g or g of f in your function that you're going to create. When something depends on something else, that's going to be an embedded function. In the previous 2 lessons, we have seen addition, subtraction, multiplication, and division. And in 8.2, we learned about embedded functions. Embedded functions are when something depends on something else. For Bertha to know how many toppers she needs to know how many cakes she will make. And for her to know how many cakes she will make, she needs to know how many days she will be opening her store, right? Okay, so when something depends on something else, that's when we have embedded functions. So let's go here. Once you're in the question, it says if she opens it, referring to the bakery, 255 days this year. Now let's go to the question. How many toppers does she need? Which of the 2 functions talks about toppers? Well, for function f of x, it says f of x is the total number of toppers. That's the question. That's the one that is going to go outside first. So we're going to say that it's f. To be able to know how many toppers I need to know how many cakes, and to be able to know how many cakes she will make, it depends on the number of days, which is 255. Again, the question gives us a clue of what goes first. How many toppers? Oh, f of x. And even if you're not able to decipher this or describe it, you can just go and see. The first function says or talks about she uses 3 toppers. The question is how many toppers, and that's the first function, so that one goes first. The second one talks about cakes, okay, and the days that she opens. So no, this wouldn't go first. It's going to be f of x. Make sure you check what the question is asking, and that goes first. And then the second one will be the next one, okay? So hopefully that makes sense. Again, the question tells me which of the 2 sentences I'm going to use first here outside. Okay, once I have these 2 functions and my embedded function with a number, this is what I do. I get whatever is outside. I get whatever function is outside, and that's what I'm going to use, but this becomes a parenthesis. My x is no longer an x, is a parenthesis. So the 3 stays, the x becomes a parenthesis. Be careful, because sometimes if you have +1, you have to put +1 in here, or plus 10 if it says +10 in here. Okay, so everything stays except the x becomes a parenthesis. After that, we go inside of the parentheses goes whatever the function inside is. In this case is g, but we're going to use this one again because there is a number in here that becomes a second parenthesis. Okay, that's another parenthesis. So 6 parentheses inside of a parenthesis. Why? Because that's where you are going to place the number, which is 255. Again, the first function is f of x, but we're just going to work with whatever is after the equal sign. We write everything except that the x becomes a parenthesis. Why? Because inside of the parentheses, we're going to put the function that is inside in here. Is the function of g of x. What are we going to put in there? Only whatever is after the equal sign, which is 6x. 6x, but instead of x, again, we put a parenthesis. And what goes in the parenthesis? The number that we have over here. Okay. Now, after that, what we're going to do is following PEMDAS. It says that before this multiplication, we have to do whatever is inside of the parentheses. The parenthesis is 6 times 255. 6 times 5 is 30. Carry 3. 6 times 5, 30, and 3 is 33. Carry 3. 6 times 2 is 12, and 3 is 15. Bring down that parenthesis and bring down the 3. We're multiplying in here. Be careful, because some people get confused and want to put plus instead of times. So now we're multiplying 3 times 15, 30. And we say 3 times 0 is 0. 3 times 3 is 9. 3 times 5 is 15. Carry 1. 3 times 1 is 3. And 1 is 4. So it's 4,590 toppers that Bertha will need. Now, if you want to check with your calculator, it will be 6 times 255 equals, that's the 1530, times 3, that's 5,590. Make sure you write your answer as a complete sentence. So Bertha needs 4,590 toppers. This year. Number 2. On a given day, machine A produces 3 hard toys for a demo and 13 boxes of hard toys. Machine B produces 2 demo hard toys and 19 boxes of hard toys. How would you represent the number of toys that two machines produce? How would you represent the number of toys that two machines produce together? Well, the word together means adding. So we can just represent as two functions, one function for machine A and another function for machine B. And then after that, we're going to be adding the two functions. So machine A produces 3 hard toys for a demo. You know how sometimes they first create some so that they can see how the production goes, and if it's good, then they go ahead and produce the rest. So f of x will be equals to the 3 hard toys that they use for demo. That's a constant. And then 13 boxes of hard toys. We don't know how many toys each box holds, but we know that it produces 13 boxes. Okay, plus. So the x then represents number of toys per box. And f of x is total number of toys. For machine B, and that's for machine A actually, g of x is represented as, well, it has 2 demo hard toys, so that means we're going to be adding 2, and 19 boxes of hard toys, so we can represent that as 19x. Okay, so that's this right here, the 2 demo and the 19 boxes. Only when I forgot to underline the 13 boxes over there. And for the last part, remember, it's just important to know that together it means we're adding the two functions. So how do you represent in function notation? We just say f of x plus g of x. One other thing that I can say is that if you wish, you can say a of x for machine A and b of x, just to use those more connected. Okay, now that we're zoomed in, f of x, we just represent it as 13x plus 3 plus g of x is 19x plus 2. For the production of this company with these two machines, we can combine like terms. And 13x and 19x, that will be 32x, meaning 32 boxes with the same number of toys, plus the 5 demo toys. Okay, plus 5. So that will be the answer when you combine those two functions. So we can say together number of toys produced are 32 boxes of toys and 5 demo toys. Do notice that I did heart toys because Valentine's is around the corner. So happy Valentine's. Okay, for this one I also had to zoom out. So it says you're trying to decide between 2 job offers. Sometimes we go through that, right? In the first job, you will earn $22 per hour plus $80 bonus each week. In the second one, less appealing, and we can talk about the reasons, but pays better, you get $25 per hour plus $100 bonus each week. How can you represent the difference between the two job salaries? And when it says less appealing, we can talk about maybe it's farther away from our job, from our home, maybe the environment, maybe it's a lot more pressure or stressed. So all of those you have to have into consideration. It does pay better, however. Okay, so how can we represent the first job offering? So in the first job, you will earn $22 per hour plus $80 bonus each week. So in a given week, we say that we can get $22 per hour plus the $80 bonus. What does the X represent? Number of hours. Number of hours. What does f of x represent? Well, when you multiply the number of hours times whatever you earn per hour plus the bonus, you get the total salary. So total money earned. Okay. And for g of x, we're going to do the same, but for the next job, for the second job, would you get $25 per hour plus 100 bonus each week. So easy. So you get 25 per hour plus the 100. So you notice that you earn more in this one than in this one, right? So in here, same, the number of hours. And g of x is total money you earn in the second job. So total money earned, but for the second job. Okay, now how do you represent the difference between the two? So we know that we get more per hour in here and also more for the bonus. So we're just going to get the bigger number and put it first. And so it's going to be g of x minus the one that gives us less per hour with less bonus. So minus f of x. Then we substitute g of x is 25x plus 100 minus, because it's subtraction, you need to have a parenthesis. And that way, when you subtract, you also subtract the 80, because if you don't put parentheses, what you're doing is adding the $80 to this job instead of subtracting it, and you can't really see the difference. So again, if it's subtraction, open a parenthesis and replace this other function, which is 22x plus 80. And don't forget to do distributive property. Make sure that you multiply by the second one as well. And don't forget to put all the numbers, of course. Okay, bring down the first one as it is. So 25x plus 100. And then negative times positive 22x is negative 22x. Negative times positive 80 is negative 80. We combine like terms, x with x, constant with constant. So 25x minus 22x is 3x. And then positive 100 and negative 80 is we subtract and leave the greater sign. So it's going to be positive 20. This means that each week you will get $20 more in the higher paying job, the second job, plus $3 per hour. Okay, if you work 10 hours a week, that's $30 more plus the 20 extra. If you work 20 hours, that's 3 times 20 is 60 more plus $20. So it all depends on how many hours you're going to work in each one and see how much that will be the difference if you would have to really compare two jobs. And also just check on if the reason is because you're traveling farther, maybe you're going to save more gas, more money on gas. Maybe if the first job is very close and you can go biking or walking, you'll save all the gas and it's going to be almost the same amount and you will be happier. But if that's not the reason and there are other reasons, then you might want to see what's best. For number 4, it says, I have a box. Its length is twice its width. Its height is 2 more than its width. How would you represent the volume of the box? Okay, so for this box, it says that the length is twice the width. Okay, the length is twice the width. Oh, it wasn't recording, so let me start. It says that its length is twice its width. So the length And because it's related to width, we're going to put L of W equals twice its width, twice the width of that same box. Then it says that the height is 2 more than its width. So the height, and because it's related to width, is 2 more than its width. Remember from previous lessons, but if you don't remember, but if you haven't seen them, more than, it does two things. First, it tells me that it's addition, and the next thing is that it switches these two. So the 2 goes to the end and the width goes to the beginning. So we're going to say 2 more than the width. Okay, whenever you see more than or less than, whatever is before that, those words, go to the end. More than its width. Okay, so it's kind of like going backwards. And then finally we have the width, which is W of W, because it's itself, we just put equals W. How would you represent the volume of the box? Let me just move this up since we have the functions already. Well, remember the volume of any box is going to be length times width times height. Okay, it's multiplication of all three of those dimensions. And so in function form, you would say that the volume is L of W times H of W. Let's keep it in the same order. The W is W of W times the height, which is H of W. So right now I'm just putting it in notation, function notation. It's the multiplication of all those functions. But then to find the expression, we would say that length of W is 2W times W of W is just W, and H of W would be, because it has two terms, whenever you have addition or subtraction, you need to put parentheses, okay? Which is multiplied by each one of those terms, okay? Addition or subtraction, put it between parentheses when you put it in the multiplication. Then you can multiply 2W times W is 2W squared. And bring down the third factor, W plus 2. In here, we're going to multiply the factor outside times each one. Is distributive property. And so we say 2 times 1 is 2. And W squared times W is W cubed. Then for the next term, positive times positive is positive. 2 times 2 is 4. And we only have W squared. We don't have anything else in here, so we put W squared. Because these have different powers, we cannot do anything else, and we can say that the volume of that box is represented as 2W cubed plus 4W squared. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the next lesson. Here you will find the link to the entire unit. And now you're able to do 8.3 and have fun.